Welcome, everybody. Thank you for joining us. This is Discover the Data, an overview of new testing on CLT assemblies. And that was kind of our working title when I started this. And now we're going to go quite a bit beyond just talking about some test data. We're going to have a kind of a broader discussion here of mass timber because we've got a couple special guests that I'll introduce in just a moment. Just some housekeeping stuff first. We've got quite a few folks joining us today, so we've got everybody's mics and cameras turned off besides the presenters here. There is a Q&A. You should be able to see that up at the top. If you have any questions or anything like that as we go through this presentation, go ahead and throw your questions or comments, anything like that, in the Q&A. And hopefully, we've got a lot to talk about, but I'm going to try and keep it so we have at least maybe 10 minutes or so at the end of the hour for questions and some discussion and things like that. Hopefully we'll have that time so we can have some questions with our guests and things like that. And we also have PAC's COO Mike Gernhardt and our sales director Steve Sorich monitoring that Q&A. So if there's some basic questions and things like that that they can answer, they can go ahead and pop those in there. So if you have any sort of questions about will recordings be available or those kinds of basic things, you can pop those in there and they'll answer those as we go. So I think without further adu, as folks continue to join us here, we'll go ahead and get started. So just to make sure, guys, can everybody see my slides? You guys see that? We're good there? Cool. All right. So first, just a little bit of an overview here. So we'll do some introductions. I'll introduce my two guests here in just a minute. Then we're going to kind of just talk generally. The three of us talk about mass timber, kind of typical things that we see in the industry, things like that. Kind of current state of the art we're seeing for acoustic, specifically mass timber. Then we're going to talk about some of PAC's IFB test data, our floating floors on mass timber. Then we'll talk about some case studies and installations of those. And we'll talk about some future work that one of our guests is doing that's some really exciting stuff in the mass timber world. And then we'll have some time for questions, hopefully. So to introduce our two guests, I had some nice pictures, some headshots that these guys sent us, but then when I went to input this in, all of the pictures came through except for those two, but hopefully you can see them actually up on the camera. So we have Felix Bernet and Simon Edwards joining us today. So Felix from Acoustic and Simon from HGC. So I'm just going to kind of read their little bios and you guys get to know them a little bit more as we talk here too. So Felix holds a bachelor's degree in mechanical engineering from the Université Laval and has nearly 5 years of experience in building acoustics, specializing in mass timber. As technical director at Acoustic, he collaborates with multiple partners to develop and optimize acoustic solutions, recently contributing to North America's first on-site KIJ tests with HGC and Simon Edwards, our other guests. He's a member of a special interest group with NRC working to integrate legislation on impact noises into the Canadian Building Code. I think Simon's also a part of that, aren't you, Simon?
No, I'm not.
Oh no, you're not.
Special group.
There's something you're not a part of that's in Canadian acoustics.
I know. There's only so much.
There's only so much you can do. I know. So that's an NRC working group, working on integrating impact noise into Canadian Building Code. He's passionate about turning mass timber's acoustic challenges into opportunities for innovation and sustainable design. Known for his boundless energy and dedication, Felix thrives on pushing limits, whether in the lab, on site until 4 a.m., or in training camps. All right, and Simon is with HGC Noise Vibration Acoustics Built Environment Division. With acoustical design experience that spans the permitting, design, construction, and post-occupancy phases of residential and commercial buildings. His extensive experience with mass timber developments, including the first Toronto mass timber building, Our House pilot project, and the acclaimed YW supporting housing project in Kitchener, Ontario. Simon is also an expert on sound transmission and a member of the ISO and ASTM technical committees on building acoustics, and a contributing member to the development of ongoing standards that govern industry-wide measurement and calculation methodologies. He's also been a speaker at the International Mass Timber Conference here in Portland and a bunch of other mass timber conferences and things like that as well, and acoustics things. So thank you guys both for joining me today. Appreciate having you here to join this conversation. Certainly add a lot to this rather than just me talking about mass timber. So with that, let's kind of just get into some just to kind of set the stage for mass timber and things like that. Just talk a little bit about kind of what we're all seeing in terms of typical mass timber, assembly types and things like that, and maybe how that's changed. Mass timber is still new, but kind of my thing is, as I've seen it, it seems like every project I see, things are a little bit different. Like it's people still kind of figuring it out, whereas in a lot of other construction types, kind of seems like it's pretty much the same thing over and over again. It's copy and paste, whereas mass timber, it's a lot more kind of project by project and bespoke. So what kind of things are you seeing just in terms of typical assemblies and then also like acoustical solutions too?
Yeah, I mean, we're seeing a lot of CLT for sure. A lot of in North America, a lot of the 7-inch CLT. It's funny, as you said, it's a developing industry, and so a lot of in the last 5 to 10-ish years, but mostly the last 5 years, we've seen more of the 5-ply 7-inch CLT. That's what we've seen the most. A little bit of NLT, a little bit of DLT, MPP as well. But now, now as we're collecting a little bit more data on 5-ply, people are saying, well, now we're doing 3-ply. We're not even doing 5-ply anymore. So it's like, trying to keep up with sort of where the industry is going. So we're seeing a little bit more 3-ply, 4 inches thick. Obviously some cost savings to be had, but some, structural challenges associated with 3-ply as well. And so that's probably the bulk of where we're seeing our work is in the 5-ply world.
Yeah, and just for anybody who doesn't know, so CLT is cross-laminated timber, right? And so it's some 2-bys that are all kind of edge jointed, and then each ply is a set of 2-bys that are 90 degrees to each other, right? And so 5-ply is 5 layers of 2-bys. DLT would be a dowel laminated timber, right? And so you have the 2-bys that are on edge, and then there's dowels that go through and hold them together. And jump in and correct me if I'm wrong on any of this, guys. And then NLT is nail laminated timber, where again, I think typically your like 2-bys are sort of on edge and they're all nailed to each other. And then MPP is a mass plywood panel, right? So it's just a really thick piece of plywood. And yeah, the thing's changing. Like I remember in, was it March, when we were all at the Mass Timber conference here in Portland, like PAC had data for our floating floors on a 5-ply CLT, which we'll present. And we're like, oh, we got these great numbers and we're all excited about it and everything. And so we were like presenting this, and everybody would show up and they'd be like, hey, what do you guys have? And we're like, oh, we've got this 5-ply data. They're like, oh, that's really awesome. Do you have anything on 3-ply? And we're like, oh man, like we're behind the times already. Like, because yeah, it keeps changing. And it's just, people are trying to figure out how to make these projects work, structurally, acoustically, but obviously financially, and for fire and all these other things. And so it is very much an evolving thing. So anything we say now may have already changed by the time
by the time the webinar is
ended.
You
watch this, yeah, by the time the webinar is ended. So okay, and so that's kind of the basic. Those things tend to be the panel types, and that's typically the floor panels that's part of your floor ceiling assembly. But then in terms of like structures, what the sort of vertical load bearing structures are, I tend to see a number of different things there. There's sort of post and beam, there's CLT or other sort of mass timber load bearing walls, and then there's hybrid structures where you have, stick framed like stud walls that are your load bearing structure, and then you have the mass timber panels. What are you guys seeing the most of kind of for construction types? And have you seen any differences in the US versus in Canada for kind of projects that you've seen and worked on?
Felix, you want to jump in on this first?
Yeah, well, at least for Eastern Canada, that's most of our job that we got. They are mostly CLT, I would say. Pretty much as you introduced to Simon. So you got some NLT, some DLT, but mostly CLT 7 inches. And our building that we got are up to, I would say, 6 stories on a concrete pedestal or a concrete structure at the base. And we got mostly dry topping solution in terms of acoustics. And I know that for, I would say, the west part of Canada, and I think you can corroborate on this, Simon, there are lots more of wet tray topping solution that are being used.
Yeah, I think we jumped the gun a little bit on the toppings, maybe.
No, that's good. That's fine. We can get into all of that and talk about these things. But so also on the walls themselves, like I was just watching.
I
Yeah,
would
go ahead,
say
Simon.
that in Canada, we're seeing a lot of hybrid construction. I think in North
Okay.
America in general, a lot of like the woodworks, wood industry folks that I've connected with and spoken to, including those in Europe, there seems to be sort of a significant economic driver for hybrid systems. A lot of wood stud systems in the US, whereas in Canada, we're seeing, I would say, maybe a bit more of a mix, about 50-50
Mhm.
on wood stud or steel stud projects.
Yep.
Okay.
Now, we are seeing some post and beam for sure. CLT load bearing walls is less common. I think maybe it's more so associated with specific um, sustainability targets or grant applications. That's where we might see a CLT load bearing wall. The post
Yep.
and beam is especially useful for commercial applications or institutional. Any wide panel where you don't have a wall every 20 feet or so, that's where we're seeing a lot more post and beam, because you can have larger, wider spaces without having to rely on the same, you can use a column instead of a full load bearing wall.
Yeah, I tend to see those in like there's academic lab buildings and things like that that
Exactly.
have
Yeah.
used that, or office spaces and things like that, because you can have this wider kind of open space. You do still have columns that kind of interrupt that completely open floor space. And then I just recently sat in on a Woodworks presentation that was talking about hybrid structures and using cold form steel. So, typical steel framing. And there they talked about that. I think for like under 6 stories, like wood framing made sense, like for the walls, so wood stud walls, and then between I think it was like 6 and 9, that steel framed walls tended to pencil out best. And then above that, if you went above 9 stories, then it was post and beam kind of structures and things like that. And I think the steel comes into play because of it's non-combustible, and so you can get better fire ratings, and maybe you can build a few extra floors because of that. So okay, so so that's kind of like what we're tending to see. And so so now this is an acoustics presentation, right? We're all acousticians and things like that. So let's kind of start talking about that. So within this, I think one of the kind of conceptions is that mass timber is especially tricky for acoustics, right, Simon? And I'll kind of let you take it from here for a minute.
Yeah, sure. I mean, I think that sort of as an acoustical consultant, like our role, we chat with a lot of architects, developers, and they come to us and they say, well, we're not sure we want to use mass timber. We've heard a lot about how mass timber structures are really weak for acoustics. And so I find it pretty effective during my presentations, our presentations, to start by validating that. I mean, yes, they are weak for acoustics. That's true. But then, we do a lot of work in poured concrete buildings as well, and we hear all these complaints from footsteps and elevator noise. So then, poured concrete buildings are also weak for acoustics. But then you hear about, all the thumping in lightweight steel frame or lightweight wood frame structures. And so then you basically get this situation where all structures are kind of weak for acoustics, except if they're designed properly. And that's sort of one of the most important messages that I find to communicate when talking about mass timber, is that yes, it is weak for acoustics. Maybe you have heard of projects that have had complaints. It's no different than having heard of other projects that have complaints that are concrete or lightweight wood frame. At the end of the day, if it's well designed, then you shouldn't have complaints. There's no reason why you will have complaints if you go into the project with the right approach and the right design. And if you don't, then mass timber is going to be no different than any other structure. You might end up having some issues.
Yeah, totally. That makes sense. I mean, we've seen lots of projects lightweight wood framed, especially where there's just low mass, low stiffness, and so you tend to have issues there and things like that. So in terms of those things, so some common assembly types. So you mentioned in concrete and things like that. A lot of times the concrete projects that I've worked on, you've got a 6 or an 8 inch concrete slab, and you'll put a thin underlayment and then your flooring on top of that, and that's usually enough to get you to kind of your code minimums. Doesn't necessarily get you to really high levels of performance, but it's on concrete, it can be pretty easy to meet those code minimums, right? In lightweight wood frame construction, we often have to do more just because there's so much less weight there, so much less mass. But so we're often using, a gypsum concrete topping, some finished flooring, maybe another underlayment on that, resilient channel for the ceilings, or sound isolation clips like the PAC Rizik 1, things like that. Maybe even springs or something if we're going for high levels of sound isolation. But those are all like pretty tried and true things, right? Like we've been doing these for a long time. I mean, even the Rizik clip's been around for I think 25 years this year. So, and we've got a lot of test data and a lot of experience with those. But mass timber, got a lot less experience with that. And I think with mass timber, I mean, especially compared to concrete, we're starting at a lower baseline. Would you say that that's true, Simon, just because of the significantly less mass that we have? If you think of just like the basic STC rating, at least like with concrete, the concrete slab by itself typically meets your code minimum. So you can kind of
I
take
think
that as a
that's
given.
definitely true. I mean, you are starting at a pretty low base. I mean, if you took lightweight wood frame and you didn't have a drywall ceiling below, then that would kind of be a pretty crappy base as well.
That
I
would be
think
pretty
one
awful,
of the
yeah.
bigger differences when it comes to, I think what you're referring to as sort of your starting point is the fact that, a lot of us on our mass timber buildings, we're targeting exposed ceilings. The aesthetic look of CLT is beautiful. I mean, it's really nice to stand in a suite and look up and go, wow, this looks different. This apartment looks different than other apartments that I built or other apartments that we've worked on. And so the aesthetic component of not doing anything below is what makes CLT and other types of mass timber unique in that, who cares if you I mean, you do need a drywall ceiling below composite steel deck or wood joists, and usually people don't really care if you have to put a drywall ceiling below concrete to address some type of upgrade. So that's maybe one of the ways that the base CLT, does have some drawbacks, I would say, acoustically.
Yeah, I think so. And Felix, you guys, Acoustic does a ton of underlayments and things like that. And so you guys do a ton of concrete projects, right? So it's pretty common for you to do apartments or condos where you put just an underlayment down and some finished flooring and you can get, that's a fairly common solution for you guys, right? On those kinds of
Absolutely.
projects. And that's
Absolutely.
kind
You
of
can,
all day, every day, right?
yeah, absolutely. You can have like a cheap or let's say a medium good underlayment and you get an IC 55 pretty easily on a floor to floor. But yeah, concrete is pretty easy in terms of solution for flooring, yeah.
Yeah. But on a mass timber, you can't do that same kind of thing,
Exactly.
right? Like,
It's
yeah.
tricky. You cannot go right on top of it. Yeah.
Yeah. So then we get into kind of what are some of the solutions for mass timber and things. But before we get into that, so I guess so first let's talk about mass timber and some of the kind of typical solutions there and some of the other kinds of acoustical issues that arise in mass timber. So first, I guess I've got this structural flanking slide up here, but before we get into that, let's kind of talk about typical solutions for mass timber, what you guys tend to see, and maybe different markets and things like that too. But what's sort of the like kind of state of the art that you're seeing in acoustics for mass timber? Either one of you go.
Yeah, Felix touched on it a little bit. Felix, you're muted, so I'll use that as a sign for me to jump in. Felix touched on it a little bit. I mean, basically because because CLT panels, like I said, we're trying to often keep the ceilings exposed if we can. That really means that if we want to do any upgrades to this separation, it has to be above. So basically 100% of mass timber projects, not just CLT, even NLT, stuff like that, they will have some type of floating topping. Otherwise, and floating topping means some type of mass above some type of isolation material, like a rubber,
Right.
for
Yeah.
example.
Yep.
And you need that basically in order to have a decent floor ceiling direct sound transmission. And so that mass, there are lots of different options there. When you just talk about mass, you could be talking about something wet that you pour, like a gypcrete or a concrete. It could be something dry, like a plywood or a cement board or like a Fermacell type sort of dry solution. So there are different solutions. Then you could go with thickness. You could do 2 layers of plywood or 3 layers of plywood. You could do 2-inch concrete, 3-inch concrete. And then you get into the isolation material and you could have rubber and fiberglass, and there are different options there. You could go with as little, I've seen probably a half-inch or just under a half-inch. 3/8 of an inch is probably the thinnest I've seen in most applications versus up to like an inch or even thicker than an inch when you're dealing with a mechanical room, for example, something
right.
much louder. So that's really sort of where your typical assortment of solutions above a CLT topping comes into play.
Yeah, and I've tended to see those like a lot of different kind of solutions come up. I mean, I worked as a consultant here in Portland for 10 years and I did a ton of multifamily and it was pretty much all like wood eye joists. and that it was pretty much always like an inch of gypsum concrete on a 1/4 inch mat, and then it was either, you know, resilient channels if they were designing, you know, trying to cut costs as much as possible, or it was clips if it was, you know, condominiums or, you know, higher end apartments, or somebody was going to actually build and hold it and they wanted to make sure that they actually got that acoustical performance. You know, we would spec Rizik ones all the time on those, but it was pretty standard, and the architects would just kind of copy and paste from project to project, and you would tweak for like an amenity space. You put clips there, you put Rizik ones there, or maybe springs or something. But in mass timber, have you seen folks kind of start to settle on assemblies, or is it still kind of changing pretty regularly, where every project you've kind of got to dive into it a little bit more?
I think, at the risk of, you know, I mean, Felix, feel free to jump in if you have some experience on the various projects too.
Well, I'm not seeing as much project as you, but as far as it seems for us, I feel like solutions are always different. Like it tends to gravitate where it's going to be a dry or a wet tray topping, but they're always kind of unique per project. As for what we've seen yet. But I've seen some recommendation from acoustician that tends to be always the same. But yeah, I feel like this growing market, everyone's not sure pretty much on what to do exactly. So I feel like it's always changing the solution. It's based on case to case.
Yeah, I mean, I would add to that, if I may, as well, that one of the cool things about mass timber, one of the reasons I really like working in mass timber, is specifically because there's a lot of advancement of research. You know, mass timber being a relatively new type of structure, you know, allows us, you know, for those of us that have worked maybe in a lot of lightweight wood frame or a lot of concrete, like Mike said, you're sort of seeing the same type of solutions. Mass timber, you know, month by month, there's a new product or new test data. Different manufacturers are coming out with different potential solutions, or there's research being done in the field, some of which we'll chat a little bit about later, that are opening up some new doors. So definitely, I would not say that a lot of my projects just use the same product. To some extent, there's obviously some cost and material availability that goes into that. There are also sustainability targets that play into that. Some projects are, maybe if they're more sustainable conscious, they might totally rule out gypcrete or concrete right off the bat and then be targeting a drier solution versus a wet solution. I would also say that, you know, for outside, you know, when you're getting into something like an outdoor amenity terrace or a pool, you know, then you have to look at a different solution than an inside solution. You also have, you know, if you're looking at a dry topping, then maybe your bathrooms, you need something wet topping in the bath. And so there is definitely a little bit of variation. Another really big thing that we've seen in terms of innovation when it comes to sort of floor toppings and how that is moving forward is how the floor topping impacts lateral sound transfer. And so maybe that's sort of a nice segue into this slide.
Great segue, Simon. Yeah, perfect. Yeah, go for it. Take it away.
Sure. So, you know, sound transmission, a lot of people, when they think of sound transmission between two spaces, we think of direct sound transmission. So that could be sound directly through a wall or, you know, directly through the floor ceiling. If, you know, my wife is working directly above me, then the sound transmission that we think of the most is what's going through the floor ceiling. And that's really important. You know, that's your STC rating, your IIC rating. Those are really important. And you should start by looking at direct sound transmission. But there's also lateral or indirect, I'll say indirect sound transmission.
Yeah.
Which is sound around the demising assembly. So, you know, that's what happens if you have a wall, for example, and you don't caulk the wall, then sound will go below the wall. And I often, I like to use water as a maybe a visual aid to sound, because people can't see sound as well. And so if you think about having a container and sticking a plastic divider between the container and then pouring water on one side, then unless that plastic is sealed, the water is sort of going to seep through the cracks below and around the container. It's not going, there's no direct transmission. That's all indirect transmission, or what I call leakage. So that's the first type of flanking, is leakage. But there's another type of flanking sound transmission which becomes really important in certain types of structures, not only mass timber, but it is important in mass timber. And that's called structural flanking, which is when sound can get into the structure itself, travel across, and come out. And so if you think about this water example, if you have like a continuous layer of foam on the bottom of your plastic container, and then you put in your divider, even if you caulk around that divider, the water is just going to go through that foam and come out on the other side. And that's very similar to how sound can get into wood or get into concrete, get into anything, and travel around a demising assembly and come out. And so that becomes really important, Mike, where you have a continuous CLT or NLT, continuous mass timber panels that are over a demising wall. And so if you have a demising wall and you have a unit in another apartment next door, first you're looking at, well, I got to choose the wall because I don't want sound to go through the wall. But then you need to look at, I also don't want sound to go around the wall, to get into my exposed CLT panels, my beautiful panels that I want to leave exposed, go through the panels and come out. And actually, a lot of lab and theory have shown that that can be a big problem. That can prevent you from meeting your code requirements in the US or in Canada. Yep. And so some of the ways that, to bring this kind of back into our conversation about floor toppings, and interrupt me if I'm kind of going on too long here, is that we have found ways to address that structural flanking through continuous CLT panels. It used to be that you had to cut the panel at every demising wall. It's a huge headache. It's a huge structural nightmare. It adds a lot of cost to projects. Maybe some of you guys on this meeting have worked on projects where you had to cut the panel at every demising wall to address acoustics. And so
And cutting the panel is an issue because part of the efficiency of using these CLT panels, part of the reason we're doing it, is you can have this big, like 60-foot long panel or whatever it is that you just crane up and stick in place that then spans multiple units of apartments or something like that, right? But if you have to cut the panels, then you lose that efficiency of now you have to have multiple crane picks to cover the same area, right? Like
100%. It takes longer, more truckloads to bring the panels in. It takes longer to install, for sure. Yep. Mm-hmm. Yep. And so we found, a few years ago during some of our earlier testing, that the mass and the damping that the topping above you applies to the wood changes how the sound travels through the wood. And so instead of getting ASTC 44, which is what the lab might suggest you should get through continuous CLT, and that red arrow in this image kind of shows you that structural flanking path. Instead, in the field, when you add a certain topping above, we're getting results 49 to 52, maybe a tad lower, 48. And for those of you who are unfamiliar, the IBC requirement is STC, not ASTC, or NNIC 45. So, an ASTC is sort of similar to NNIC, and so an ASTC rating of 49 or 48 would really essentially meet those code requirements. That would be okay. And so we have found that you can keep these panels continuous, but I guess sort of tying back to that original conversation on toppings, not all toppings allow you to keep those panels continuous. Some toppings, if you have a really, really thick isolation material, then your topping won't change how the sound goes through the wood enough. And now it will go back to the way it was in the lab, and then you get really like a low performance in the field. So that's how we have started thinking about how we can use these toppings, wet toppings, dry toppings, roof toppings. That's another important one. You know what I mean? If your top floor units with exposed CLT ceilings, whatever's going on the roof has to also change that structural flanking. So kind of thinking about how we can use our floor toppings to address the structural flanking as well.
Yeah, that's all great. And just to kind of keep us moving here, so so this question of the effect of wet toppings, so heavier toppings versus dry toppings, has been a question that I know people have been talking about for a while now, and you have been able to kind of go out and start collecting some actual field data on this and some other potential solutions here, right? So
That's
I'll
right.
let you
Sorry, I
kind
just
of
want
talk
to
about
interrupt for one
this.
second. If you go back to
Yeah.
that photo, I can't let you go past that photo without first addressing it. So it looks like we're measuring ghosts in that photo. That photo was actually
Don't
taken
all
by
acoustic
Felix.
measurements look like measuring
All acoustic
ghosts or
measurements
ghost
look like we're
hunting?
measuring ghosts. That's right. So the secret is out. Don't tell them.
Yeah.
So this is called KIJ testing. This is basically how we measure structural flanking. It's a pretty brutal test. This photo was taken by Felix, and I actually on a project where Felix was supplying the topping, and this was in Brooklyn. And in your bio for Felix, you said something about whether or not he's working at 4 a.m. and I started laughing. I was on mute because this project we were doing this testing until like 3:15, 3:30 in the morning, and so there is some bonding that takes place when you're measuring vibration until 3:30 in the morning. But yeah, sorry, please continue.
Good
Yeah,
times.
I think I got some text messages from Felix. It was about as I was waking up or like, as I was about to go to bed, and it was like, 3 in the morning or something like that. And he was like, "Hey, look what I'm doing with Simon." Yeah. Um, so you've been kind of digging into this, right? And sort of looking at this flanking across a space. And I want to kind of keep us going here to make sure we get those things. But this is an important one too. So I want to kind of talk about this. So could you sort of set the scene for us of what this project was and
Sure.
kind of what you looked at?
Yeah, definitely. So I'll give some kind of high level approaches. So in addition to addressing your structural flanking, which is a big issue in mass timber acoustics, in addition to looking at how the topping can affect that, there are some other solutions. I mean, ultimately, you want to reduce the amount of sound getting into your ceiling and then coming off the ceiling in the next apartment over. And so one way to do that is by putting a drywall ceiling in an intermediary room. So in this example, you've got your demising wall. Let's say you have a bathroom along the demising wall, and then you can leave your mass timber exposed in the living room or the bedroom, for example. And what we have found in some of our testing is that can increase your STC by about 5 to 6 points. So already that's a great solution for people who, people say, well, what's the right time to involve an acoustical consultant? And so, when I'm talking about getting involved as early as possible, we're talking about, well, the conversations that take place where we say, where are we going to put the bathrooms? Where are we going to put the bulkheads? Where are we going to put the, things like that can take place so early in a project design can have a big impact on acoustics without, the point is to not add more costs. So instead of saying, oh, now you got to put a drywall ceiling in your bedroom, which you weren't planning on spending anyways, we just say, look, let's just put the bathroom here instead. Now we've found a way to just use the bathroom as that acoustic buffer between two areas of exposed CLT without incurring more costs for the project. So that's sort of one solution. We can jump into. Sorry, please.
I'll interrupt you there for a minute, just since we're talking about ceilings, because initially when we started talking about mass timber at PAC and everything like that, we're like, well, I know the solution, just put a ceiling on it, but obviously people don't want to cover it up. And though as you do go taller, you get into the, I don't know where it is, 8 or 9 stories or more, something like that. As you get taller, you have to cover up more and more of your wood for fire and things like that. You have to encapsulate more of it, and typically that encapsulation is drywall, so you can do that, and then you have that. So that is a thing, like a dynamic here that also changes depending on your building type, how high you're going and things like that.
Yeah, you can go pretty high. I mean, we're doing 13 stories right now in the US with exposed CLT ceiling. So I mean, you can definitely get pretty good heights, especially as the fire codes in Canada and the US continue to advance. We're seeing less requirements for encapsulation.
Yeah. But there is also FP Innovations. We've mentioned Woodworks. That's one great resource for a bunch of information and stuff like that on mass timber things. They have acoustical assemblies too. FP Innovations does as well, and I didn't get a chance to put it in here, but they do have some test data in there, acoustical test data for CLT assemblies with drywall ceilings, and they have some even with our RISC 1 ADM. So our clip that's a version of the RISC 1 that you can attach to the ceiling, and so you can get that there. So there's different ways to easily attach a drywall ceiling and get this here. That could also be used to do, let me go. Yeah, so here I'll let you then kind of talk through these bulkheads, Simon.
Yeah, I mean, I'll just very briefly add on. So this is some additional testing. We actually did this pretty recently. This was another Acoustic project, so I wanted to make sure that these are really interesting data to share for sure. We were looking at, okay, well, what if we don't want to drywall a whole room? What if we want to just look at bulkheads? And again, this just comes into good design decisions early in a project where you have continuous mass timber panels. Can we place our bulkheads at that point? And also getting into the idea of, do we need bulkheads? Do we not need bulkheads? When we talk about how the topping affects the flanking, what we have found is that a dry topping, because it's just lighter weight, is not as effective at addressing the flanking. Well, okay, does that mean that you can't use dry toppings? That's not what we want to have as a solution, because there are a lot of benefits to dry toppings as well. And so it's more about, okay, great, if we want to use a dry topping, then what's the solution? And so we recently did some testing where we had the Acoustic Sofix dry topping with above a 5-ply 7-inch CLT. And we tested between two adjacent bedrooms where we had no bulkheads, one bulkhead, meaning like a bulkhead only on one side, or two bulkheads, a bulkhead on two sides. And the data was really, really interesting. We got, if you go to the next slide,
Yep.
We got ASTC 48 to 50 to 52. You see almost like a linear increase in acoustical performance as you add a bulkhead, which also means that, you can toy with your goals as a building designer. If you're designing affordable housing and you're saying, look, I just want to meet code, that's it. That's the one approach to go about it. If you're saying, no, well, I want an STC 55 or a higher target, then you can look at, okay, well, I can still have my exposed CLT, and maybe I can even still have continuous panels, but I'm going to put my bathrooms along the wall, or I'm going to put bulkheads, or these are solutions that help us achieve these higher targets without having to cut the panel at every demise wall. That's what we're really trying to avoid. And the main, just one last thing I'll add, if you go next, Mike, I think there's a.
I don't have another slide after this. Oh, is there an animation?
Yeah, that's right. Okay. So this is the frequency range between 315 and 800 hertz, where the structural flanking is the worst, where that often like a test might fail code because of these frequencies. And so that's just what I wanted to highlight of this graph, is to show that's where we get the biggest improvement from these bulkheads. So it's kind of cool to see, and we really appreciate everybody that was involved in making that data available to the industry.
Yeah, and so before I go in and I start my portion of talking about, dry topping test data and stuff like that. Like, so in this case, you had a 5-ply CLT. Was that 5-ply CLT continuous across this demising wall, or was there any sort of cut in it?
It was continuous across the demising wall, and the demising wall was a steel stud wall, non-load bearing. It was a post and beam system. But even with load bearing, we would expect the same type of performance.
Yeah, and so this was a continuous 5-ply CLT with a dry topping on it, and that with no bulkheads, you still got ASTC 48, which is
that was really interesting. That was
really cool. Comparable to what you presented before for the other flanking data that you had that had a wet topping on it.
That's right. That one 48 had, the 49 was was an inch and a half of gypcrete. So, and then as you get to like 2 inches of concrete, we were at like 51. So that's right. Like as the mass increases, you can see that flanking increase too.
Okay, so it is possible to get there with a dry topping without the bulkheads to meet those code minimums, and then you have now some data on these bulkheads to show that like this is a way, like you said, to kind of continue to improve your performance with dry toppings if you have higher targets for your building.
Yeah, I mean, ASTC 48 is pretty close to a lot of code minimums, so I probably would not recommend designing a building with a dry topping and no bulkheads. Usually, first of all, you'll have one bulkhead anyways, at least as part of your mechanical design. So that's
bathroom
good.
Exhaust fan, kitchen exhaust.
Yeah, going forward with zero bulkheads might be a little risky. So planning for at least one bulkhead is probably a good decision.
Yeah. Okay. Cool. All right. Well, that's all great information. I know that this is something out there that's been a big topic of conversation, things like that. I know you've got some additional work on it that we'll come to at the end of this if we have time. But so now, we've been talking about kind of dry toppings, and so now I'll kind of go into some data here, and on time I'll kind of go through these fairly quickly. So I have a bunch of different test data here. This is all fairly recent test data from PAC laboratory test data. So now we're all talking about sort of direct sound transmission. So STC and IIC laboratory measurements. And all of this test data is available on PAC's assembly selector, online assembly selector, which Mike or Steve, if one of you can throw a link to that in the Q&A for folks, you can go and you can get all this data. You can see the test reports and get more access to this. So here, just kind of starting, we've got sort of basically 3 different kind of assembly types, and we have a 3-ply, and then we have 2 different 5-ply assemblies, and then in the bottom left we have this weird 3-ply and 5-ply, and this was actually the first mass timber test that we did. It was a I think kind of design build manufacturing firm, Green Canopy Node out of the Seattle area, that was looking at doing modular mass timber. And so they were going to have these, mass timber units where I think the floor of the upper module would be a 3-ply CLT and the ceiling of the lower module would be a 5-ply CLT. And so they were going to stack these units on top of each other. And so they were looking at how to isolate these. And inside of a unit, they were also going to do a raised floor where they could run services in that floor. So they were looking at isolating that, but then also isolating the modules from each other. And I was like, you guys are building this in the Pacific Northwest. This is a seismic zone. How are you going to isolate these modules acoustically, but then also deal with seismic bracing and stuff like that? So I was like, let's just try first, like screwing the things together and then isolating this floor inside. So that's kind of where we started with. And that was the first thing that we got into this, and then started doing this other test here. So you can see, again, all like fairly low ratings for both STC and IIC. But then as you start adding these dry toppings to them, immediately your STC ratings and your IIC ratings all improve significantly, right? And these are all pretty much the same kind of buildup. So it's all the same isolators. It's the PAC IFB, which is a 2-inch by 2-inch polyurethane foam isolator that you can space at maybe 16 or 24 inches on center. And we'll show some installation kind of photos of that later. And then here the subfloor is, usually 2 layers of like 3/4 inch plywood, and we've got some insulation in the cavity. So this is a dry topping, fairly quick and easy to put together, but you can get really good numbers. And this is just bare plywood. And then when you add a finished floor onto this, you get even better numbers. So these are, STC ratings in the high 50s, low 60s, and IIC ratings in, again, the high 50s, low 60s also. And so you can get really good ratings off of these, far above just the code minimums. And then, you still have to consider the flanking pass and those kinds of things, like Simon talked about, but now you've got some tools and resources for those as well. So just to dig a little bit into this, and also just for some comparisons, right? So we've talked about, to Simon's point, this idea that like mass timber is weak, but really like, all construction types have their weaknesses for acoustics. And so just to kind of do some comparisons here. So on the left, we have floating floors on mass timber, and on the right, we have floating floors using the same PAC IFB and 2 layers of 3/4 inch plywood on concrete. And you can see that like the ratings are pretty close. Now,
Oh, that's
I'm
cool.
not here to say that you can get mass timber to be as good as concrete, because concrete has additional mass, it might be different at low frequencies and those kinds of things, but we'll dig into some 3rd octave band data too and show some other comparisons.
Something, Mike, I think is just cool for
Yeah.
me to add on this product here, because I used I think I used the bottom one on a project very recently, and it was specifically useful where we had an indoor amenity space beside the outdoor amenity space, and so there had been a depression in the structure to allow for the roof buildup for the outdoor space to be consistent. And so now we were looking at, well, we need a floor topping in this building where we can actually make the floor topping deeper in one space for the amenity space. And so this was really cool, because you've got these pedestals for this version of it that allows you to sort of go, well, let's just sort of customize the pedestal height to make sure that we have all of our floor heights the same. So that was sort of a cool practical thing.
I've actually got some photos of that we'll show at the end if we have time for them. So that's awesome. And that, that was all data that was, available to you where you could go access it. And I think there's a link for that now in the assembly selector. So here, so I'm going to go through a bunch of data now, right? So this is the kind of the data heavy portion of this. But I'll kind of go through these relatively quickly, just point out a few things. And again, all this data is online and you can dig through it. So here we have just the basic transmission loss values. And so just to orient everybody who's not necessarily familiar with looking at these, on the x-axis or the horizontal axis, we have frequency, and that goes from low frequency on the left, so like bass notes, things like that, booms and things, to high frequencies on the right, so clicks and clacks, high pitched sounds, things like that. And then on the vertical axis, the y-axis, we have, in this case, the transmission loss value. So that's basically how much the assembly reduces the noise going from one side to the other for airborne noise. So higher numbers are better. So here, kind of all clustered together, you have the 3-ply and the 2 5-ply CLTs. And then the one that kind of goes up significantly on the right is the combination of the 3-ply and the 5-ply. So I thought this was interesting that down at the low frequencies, having 2 of them, additional mass and stiffness, really didn't do anything. And it was only at this like mid and high frequencies where it made a difference. And I know we could spend the rest of our time and more talking about that and why that might be, but I'm just going to leave it there for now. So here's the 2 5-ply assemblies, and I present this just to show that there is difference in these assemblies, right? Different manufacturers will have different thicknesses of 5-plies. They'll use different wood. There's also just inherently some variation in tests. Even if you just go test the same assembly or the same general 5-ply from the same manufacturer, you will see some differences in things like that. So if you see small differences, 3 points or less, especially in acoustical test results when you're comparing them, even same sort of thing in the same lab, like take it with a grain of salt. There is some variability in these things. So another thing to look at when we're looking at lab test data is to make sure that we're actually measuring what we think we're measuring. And so Simon talked about flanking, right? These other paths that sound can be transmitted around the main thing, assembly that we're using to try and block the sound. So that's certainly a critical thing to consider in the field, but it's also an issue that we run into in the lab. Like labs are designed to have much higher flanking limits, but they still have a flanking limit. There are still some ways for sound to get around. And so here you see the blue line, which is the flanking limit for the lab where we did these tests. So all of these things well below that flanking limit. So we know we're getting, clear differences between these. We're able to distinguish between them. And just for some comparison, some kind of level setting, here's in orange is a concrete slab. So this is just a bare concrete slab. So we can see that, just the 3-ply and the 5-ply CLTs, way lower transmission loss than just I think this is a 6-inch concrete slab. But when you start combining the 3-ply and the 5-ply, it kind of, again, some interesting things happen at high frequencies, but high frequencies usually aren't the issue for us for sound transmission anyways. But also in variation, here's the orange lines are 3 different tests of essentially the same concrete slab from the same lab. So you can see, especially at very low frequencies and high frequencies, there's quite a bit of variation. So again, if you see some variation in test results, could just be random variation, not necessarily differences between products or something like that, right? So here's now these are the impact sound pressure levels. So before that was all airborne sound transmission dealing with towards the SDC and transmission loss. And now we're looking at impact sound pressure levels. This is for impact sound. So we have a tapping machine that taps on the floor up above and we measure how loud it is down below. So again, on the x-axis, we have frequency from low on the left to high on the right. And then here on the vertical or y-axis, we have the impact sound pressure level. So just how loud is it in the room below? So in this case, lower values are better. And again, you can see that kind of clustered, those lines clustered together. Those are the 2 5-plies and the 3-ply. They're all about the same, with some variations. But then again, this 3-ply, 5-ply kind of combination rolls off the levels significantly. So kind of interesting data. Maybe there's something to do with that. But again, here's the 2 5-plies. So there is a little bit of variation, a little bit less in the ISPLs than actually in the TL values. And then here's concrete. So I think this is interesting that like in this kind of mid-low to mid-frequency range, the mass timber is much louder than the concrete. But then in high frequencies, you see the timber is actually quieter than the concrete. And that's just because of the stiffness of that concrete. You get that really high frequency kind of almost ringing from just impacting on a bare concrete slab, whereas the wood sort of damps some of that high frequency sound. So, even for just bare CLTs, there are some, some frequency ranges where they're actually better than the concrete. So it's not always just so simple as being like, this one's better than this one or something, right? There's nuances, and this is why you hire folks like Simon, is to dig into all of this kind of data. And again, we've got some variation with concrete slabs. Again, same basic slab tested at the same lab, just different times, different years. And you can see, especially at low frequencies, there's huge amount of variation there. So here's what happens when you add floating floors. So now this is the transmission loss value for all of these, the 3-ply, the 5-ply, and the 3-ply, 5-ply combination when you add the floating floors. So you might look at this and say, oh, somehow like adding the floating floors, it's magic thing that it equalizes the TLs of all of these assemblies and things like that. But if we compare to the flanking limit, the blue line now, we see, oh no, these are all equal because we're starting to approach the lab's flanking limit. So in this particular instance, even just adding the floating floor with the pack IFB, so 2 layers of plywood, the IFB, to a 3-ply CLT, got it close to sort of the maximum that the lab could measure. So we're getting into this like high SDC 50, low SDC 60 range. And so there is some chance that, you know, in a lab with a higher flanking limit, these might get even slightly higher transmission loss values than this. But it shows just the level of performance that you can achieve even with a, you know, relatively lightweight dry buildup. And then here's concrete for comparison, this orange line. So you're saying that adding a floating floor is getting us to these kind of TL levels of what you would expect from concrete. So you can kind of start to level match these things. And then here's our impact sound pressure levels. Here we're actually seeing some more variation. So seeing that the heavier, thicker assembly, the 3-ply plus the 5-ply, gives you better or lower values. And then here's concrete for comparison. So both in the transmission loss values and the impact sound pressure levels, the concrete and then the CLTs with the floating floors are fairly similar. So you can kind of start to use these floating floor assemblies to kind of get you into that kind of similar ballpark. And then here's the bare concrete just for comparison to show the variation at low frequencies. So if you kind of look back here, you can see that, yeah, the CLT and the concrete are all fairly similar, similar range at a lot of the frequencies, but the concrete's significantly better at low frequencies. But if you include the variation at low frequencies for the concrete, the CLT panels are all kind of within that range. And then here is if we add flooring to those floating floors. So we drop it down even more. And then here is concrete with floating floors. So earlier on, I did that comparison that Simon was really interested in, where I had the CLTs with the floating floors and the concrete with the floating floors. And this is that in terms of the third octave band impact sound pressure level. So it's not just that at some particular frequency that controlled the IIC rating that they were similar, but actually across the whole frequency range, they're within the same ballpark, right? And so this is the floating floor with the pack IFBs with an engineered wood floor, I think actually on an Insana floor, which is a product from Acoustic and Suprema. And so with that, you can get similar things to even floating floors on concrete. So you can start to get, high performance levels of, sound isolation on these kinds of assemblies. And then the other interesting thing here is, like we've been talking about, there's a lot of variation in mass timber, right? And so you've got 5-ply CLTs, you've got 3-ply CLTs, you've got CLTs from different manufacturers, you've got DLTs and NLTs, which there's less data on, you've got mass plywood panels and these kinds of things. So, what do you do if you've got some project that's got some new kind of, mass timber structural system, and you're looking at like, okay, what kind of results for acoustical performance am I going to get on it? But you can't find any or much test data for it. So I realized that I had tested the exact same basic floating floor buildup, a couple layers of plywood on the pack IFB on, 4 different, a bunch of different mass timber assemblies. And so I wanted to see, did I get consistent improvements from that floating floor that then would allow me to kind of go and predict on other assemblies. And so here what you have is the deltas. So this is the change in the impact sound pressure level of the assembly when you add the floating floor to the bare CLT panel. And so this is for the 3-ply, the 2 5-plies, and the 3-ply plus the 5-ply. And you can see from, I can't quite see the frequency range, but maybe it's from like 1,000 hertz or a little bit above that down. They're all very similar. And interestingly, even if you add concrete, because again, I've tested the same floating floor buildup on concrete, that's the orange line. Even in that fairly wide frequency range, the deltas are the same. So what this indicates to me is that you can use these deltas, this change in your impact sound pressure levels, to predict what this floating floor might give you on other assemblies if you just have the bare assembly test data. And so I went and actually tried that out, and here's kind of the comparison between the black and the blue lines, and you can actually get pretty close in your predictions. So this shows you can go take this data, you can go do predictions for other projects and things like that, because this, you know, keeps changing quite a bit. So that's all of that. And then I'm gonna go just in the interest of time to this other project, because this is the one that Simon mentioned. So this is that project where they had these kind of this riser system to level it to, you can kind of see there the door in the back, right? So I think that was kind of the outdoor amenity space, and so they did this, and so you can see here the IFBs underneath this, and kind of here's the installation of where we did this. So we did a, you know, I and Ty, our CAD draftsperson, did a layout for these. We got from Simon and Felix where exactly the structure elements, these joists were going to be, and then we lined up the isolators with those to put those in here. And Simon, have you had a chance, or are you going to have a chance to go do field tests on this project, or is this one that's done and
we've done some field testing on this project, but the field testing that we did wasn't the project wasn't ready for field testing on this floor. Like, this is the top floor of the building, and so we're actually going back tomorrow.
Oh, really?
Tomorrow to do some testing on this project.
Oh, dang it! We should have pushed this this presentation back
a couple
by
48
weeks.
hours.
Yeah, about 48 hours, so we can have the data. Well, is that something that maybe you're gonna present in the future at a, you know, an ASA session or something like that will be out there?
Yeah, no, it'd be cool. I mean, we'll take a look at the data and what we can definitely chat about, you know, where to go from there.
Okay, awesome. Yeah. So then, real fast, because we're getting really close on time here. So I just want to give you just a minute or two, Simon, to talk about this this study that you're doing.
Yeah, I'll keep it very simple. So, you know, we spoke about the CLT flanking through continuous panels, and so really, like, one of our main goals is to not have designers, you know, not require them to cut the panels at the demising wall. So coming up with what are more and more and more ways that you can keep the panels continuous. And so better understanding what happens when you go from concrete to a dry topping, or you go from 2 inches concrete to 3 inches concrete, or you go from a 1/2 inch drywall or a 1/2 inch isolation to a 1 inch isolation. What happens when you go from load bearing walls to non-load bearing walls? So look, we're looking at doing probably about 70 to 80 tests, a lot of tests of totally different toppings, one topping after the other, as you can sort of see on this list, playing around with all of these different materials, different manufacturers, and making this data public. We're partnering with a lot of fantastic people. So sorry, the mock-up is going to look something like this, where we sort of got 2 rooms with continuous panels. We want to test what is the structural flanking with all of these different toppings above, as well as what is the direct sound transmission through those toppings as well, and then make all of that data public. We are doing this testing with University of Northern British Columbia as our main partner. We're also partnering with Woodworks, Element 5, Forestry Innovation Investment, Canadian Wood Council, National Council of Acoustical Consultants, Forest Products Lab, Aspect Engineers, and then lots of you know, some great manufacturers have you know, joined us and are willing to contribute their products and be part of this research, including PAC, Acoustic, and Suprema. So that is, you know, that data we're probably looking at. We've applied for some pretty significant grants that we're actually expecting to hear back from within a month. So timeline wise, you know, I'll release more updates to you, Mike, as we get info on these grants, but probably we're looking at publishing results in Q3-ish of next year, Q3, Q4.
Okay, awesome. Yeah, so if anybody's, you know, if anybody's interested in this, there's manufacturers out there that aren't part of this already, you're interested, you can reach out to Simon, or anybody's just got money burning a hole in your pocket, I'm sure Simon would take it for this too. So
we would take it for the research.
Yeah, thank you for putting this together. Simon and HGC is involved in this. So, all right, with that being said, we've got 1 minute left for questions. I am happy to stay on after if folks have questions, if people want to. And Simon and Felix, I know your time is valuable. You got a lot going on, so if you need to duck out, by all means.
I can stay on and answer questions as well.
And Mike, we've got several questions in the Q&A.
Yeah, I imagine so. So Simon and Felix, thank you both for joining and for contributing. And yeah, Steve, hit us up with some questions. What do you got?
Okay, starting from the bottom here, Matt Kinch asked, how How are you addressing exposed CLT glue-lam beams that are part of a demising unit-to-unit partitions? So if you have a glue-lam beam running through a demise wall from unit to unit, I guess I would assume, Matt, are you referring to flanking through that? Would be my guess.
I think, yeah, and Simon, I'll just kind of let you, Simon, you actually had a slide in your presentation that you sent me that actually showed this, yeah.
I think they're probably referring to direct sound transmission. We get this question a lot. If you have a glue-lam beam and then you have your demising wall to the underside of the beam, then are you going to have a problem with the sound going through the beam? And the answer actually is yes. I mean, just as Mike showed with the CLT direct sound transmission, it's low when you have nothing on it. So either what we would do is, I mean, in general, we'll only expose the beam and column on one side of the demising wall. So you kind of have to pick and choose which resonant you like the most. And so one option is either to extend the stud to the underside and then put a little insulated partition on one side. Or what you can do is, sometimes what we see is put the stud right on the outside of the beam, put the stud to the underside of the top of your CLT, and then maybe on one side, if it's a single stud wall, on one side of your studs, you can bring the drywall up to the underside of the beam, for example. So that way you sort of shift your stud wall by about 6 inches, put it right beside the beam. That way you've got that insulated stud on one side of the beam, and then you've got the exposed beam on the other side.
Yeah, and so there's also, in terms of flanking transmission and things like that, like if you have these assemblies and then your wall goes and ties straight into that structure, then that wall could also potentially be a flanking path too, depending on what your toppings are and how exactly sound is getting into that CLT panel that then's connected to your wall. And so there's also ways where you can isolate that top track. So
absolutely,
Pack has the RISC U and the RISC U HD, which is a rubber isolator like the one in the RISC 1 with a steel plate that attaches to your top track, so you can isolate that wall from your from whatever the structure is above. Like we do it a lot in high-rise concrete construction, but you could totally do it in mass timber as well, as long as it's a non-load bearing wall. If it's load bearing, then obviously that's different.
Yeah, Matt had made a comment in the chat. It's been his approach for that condition, but the architects have been asking for the beam to be exposed on both sides.
Yeah, that's a tricky one. I'm not really sure how you would find a way to get. I mean, you would do two beams, because for the beam to be exposed on both sides is just, it's like saying we want the CLT floor ceiling panel to be exposed on both sides. I mean, then what else are you going to do? I mean, it is what it is. So you can build a beam. If the beam is wide enough, then maybe the direct sound transmission through the beam, maybe if the thickness of the beam might be sufficient, but in general, it's going to definitely be a weak point.
Yeah, something else that we've talked about at Pack is, like instead of exposing the actual beam, like if the idea is to get the look of it, but you still want the sound transmission, you could create a surface outside of the beam that looks like CLT or glue lam. So you could do a faux surface. So you could do, RISC clips attached directly to the beam if it's allowed to attach directly to the beam, and then on the clips and the hat channel, instead of putting drywall, you could put plywood, and then put some wood paneling over that mimics the look of your CLT. You could use the same of your glue lam beam. You could use the same type of wood and things like that. You could do those kinds of panels and things like that would then give you significantly better acoustical performance while still kind of maintaining the wood look, but not actually exposing the beam.
Yeah, we've done that if you have like a really loud amenity space right below an apartment, for example, or a commercial space, a loud commercial space below an apartment, where you want the look of the exposed mass timber, but you're going to get a lot, like a normal residential separation would not be sufficient. You should have an upgraded ceiling. Then we'll do exactly what you just said, Mike. We'll actually do a faux, like a false acoustic ceiling, where we'll do like a proper acoustic ceiling with RISC isolators, whichever insulation, and then we'll end it off with something that sort of looks like the same mass timber panel, and it has the same look.
Yeah, and with like our clips and also our spring isolators and things like that, we do a lot of like really high-end, like stupid expensive high-end homes where they have wood coffers in their library and stuff like that. So we do a lot of things where we've got all kinds of different decorative wood paneling. It's not necessarily to mimic the look of a CLT or a glue lam beam, but there's lots of different ways to do that, and it's something that in other areas we've been doing for a long time. So all right, Steve, what else you got for us?
Okay, next question is coming from, one second here, they're popping in pretty quickly. Next question comes from George Cordes. If you could go back to slide 16, he had a question about bulkhead. Was the bulkhead framing isolated from wall and ceiling?
No, it was not.
Okay.
It was insulated.
Get all the way back to...
It was insulated, but not isolated.
Okay.
Like this right here. So it was insulated, but not
slide
isolated.
16, yeah. Okay, or 15, yeah, it doesn't matter. 15,
yeah,
it's a bulkhead picture, yeah.
Yeah. So this data. So it was not isolated. So it was just like typical like steel framing, like attached directly to the structure. Okay. So do you think that isolating that would have given you even better performance, or do you think that it was the main transmission path was still through the CLT? You just made the sound take a longer path, and so
that's exactly right.
more.
Yeah, I don't think that isolating the bulkheads would have a specific role in this.
Yeah. How wide were your bulkheads?
That's also relevant. That's a good question. I mean, these ones were about a foot wide on each side.
Oh, okay.
But hypothetically, if you had like a 2 feet wide bulkhead or a 3 feet wide bulkhead, then that would, have similar effects.
Yeah, right. Because it's really the distance that the sound has to travel through
That's
the
exactly
CLT
what
panel.
it is.
The longer that distance is, the more dissipation you're getting as the sound travels through.
That's
it, right?
exactly right.
Yeah. Okay. So that's another tool that people could play with. Is that something in your flanking studies that you're going to do? Are you going to play with different sizes? Okay. Yep. Awesome. Cool. All right. What else?
On the same subject of bulkheads, Dan Beckman wrote, can we talk about the bulkheads again? Do you have an idea about the mechanism which is providing the improvement the bulkheads apparently provide? It seems like you're just closing up the wall ceiling seal itself. Is the flanking still passing through the joint rather than entering the ceiling slab then exiting it?
I would say that it's like we just said, like I assuming that the wall is already well sealed, which I think if you got an ASTC 48 in this case, then that wall was already well sealed to the structure and things like that. You weren't getting just leaks, right? And so by adding these bulkheads, you weren't covering up leaks. You were increasing the distance that the sound had to travel through the CLT panel to get from one side to the other, and so there was some dissipation there. Yeah,
that's right. And again, if you kind of come back to this idea of a plastic container with a continuous foam along the bottom, then if water gets into that foam, by separating how far the water has to travel before it comes out of the foam is kind of what would lead to the reduction in sound coming off the ceiling. And this kind of picture, we actually didn't talk about it, but this picture here is an acoustic camera. So it's sort of a visualization of sound. And this is a situation with a steel stud wall and a continuous CLT panel, where you have a loudspeaker on the other side of this wall for an STC test. And you can actually see that, the sound in this case is coming off of the ceiling and not coming through the wall.
Yeah, and if this were a leak, you would see a big red line.
You would see a big red line right at the corner, whereas instead it's just sort of coming off that wood. Now this was I think this was still like an ASTC 50 performance, so it was okay.
Yeah. Okay. All right, Steve, what else?
Okay. All right, Ben Toes asked also, you talked a little bit about flanking in testing from the underside, but could you talk about flanking through floating topping assemblies? Do you typically see wall framing remain on top of the topping or going down to the base timber panels below?
That's a good question. Simon and Felix, what have you typically seen, like either when you have a wet topping or when you have a dry topping, like where are those walls placed? And I guess also let's differentiate between load-bearing and non-load-bearing walls too.
Well, for my part, I would say that the mising wall that are going all the way through to the CLT itself, and then you can have topping exactly shown like on this image right here, and this is typically where we're seeing. Simon, do you have something to add?
Yeah, I mean the question is a good one, Ben. You're right. Like you can't have continuous floor toppings because then you will have flanking through the floor topping as well.
Yeah. So
the wall has to interrupt, or let me rephrase that. The topping has to be interrupted at the wall in order to avoid floor-to-floor flanking. Now there's some different ways to do that. I mean, sometimes what we see is they just saw cut the topping and then they build their wall and that's it. Another way we see it is the wall goes down to the bottom. Now people ask, well, I want to pour the toppings or install the toppings before I install the walls, and how can I do that? And so a few approaches are to use really tall bottom tracks, or you can, and tall bottom tracks allowing you to sort of then install your topping with perimeter board and then build the wall after. The alternative is to put down a couple 2x4s. That way you've sort of delineated where your demising wall is going. Then you can put your topping on. You have made sure that your topping is not continuous, and then you can deal with the wall after.
Yeah, you could also, I mean, depending on your wall configuration, like if you had a double stud wall, you could, with the plywood floating floors on the pack IFB, just cut it, have the floor stop on either side, and then you could actually have the walls, the studs off of that floating floor too. I mean, that's the thing that we can accommodate that load as long as it's non-load bearing walls and things like that. So there's a lot of different things to do there. And again, like Simon mentioned at one point, that's a thing to have a conversation to have early on with your acoustician. Like do that in the SD phase so that you can kind of figure out a rough idea of how you're going to treat those details, moving forwards through the project, because that can have a lot of sort of, impact a lot of different things in terms of, the order of the trades when they come in and do things, and, the different solutions and the different products involved. Yeah. But good question. All right, Steve, what else?
Okay, next one comes from Annie Joe. He said, did you normalize results for panel thickness, e.g. 5-ply versus 7-ply, or vary layup orientation, or test MEP penetrations through the bulkhead dry topping stack to see whether the bulkhead improvement holds? Added mass versus orthotropic stiffness may shift coincidence frequencies.
Wow, there's a lot there. So what I'm hearing is, one, just generally speaking, your bulkhead test was one wall, one configuration, one project, right?
Correct.
So and it was a continuous 5-ply, and the data that you had was just the data that you got. There's no sort of adjustments, normalization.
Yeah, it was not a lab
right?
where we could play around with different configurations.
Yeah. So needless to say, it's one data point. It's not conclusive for all conditions, but it is good information to show. I mean, I think the relative improvement of the bulkheads is very useful, but certainly, I mean, you're doing the big study where you can play around with some of those other things, right?
Exactly.
Yeah. And that's I mean, and for folks like that have more detailed questions, like we'll send out a follow-up email from this, and feel free to reach out. And if you want to just contact me or us at PAC directly, but if you have questions specifically for Simon or Felix, we can send questions to them too and kind of keep those conversations going. But yeah, I feel like there's a lot to dig into that one, but maybe more so than we have time for. But I think just that it was a general sort of a single sample of a space is probably addresses a lot of the other questions. Yeah. All right, Steve, what else?
Okay.
We'll take a few more. We still have like almost 90 people on here, so we'll keep going for a little bit. But
yeah, there's only a couple more questions, Mike.
Okay, cool.
At least in the Q&A here. Tony Hoover asked, for the timber component, do CLT and DLT and others perform similarly, presuming same thickness?
No. Fast answer is no. If I can jump on this, CLT is cross-laminate timber. So you got your first layer, and then your second one, and then your third one, and so on and so on. Compared to DLT, where it's only layer like this, and they're jointed together. And since depending on the mass timber type, the joint change, its leakage performance change as well. So if you're looking at CLT compared to DLT, its ratings, it's definitely going to be better with CLT since it tends to have less leakage, as well as compared to NLT or every other type of mass timber system. So in terms of performance, CLT would be the best, and then you will have all the others below. Maybe Simon, you can comment on this.
No, I mean, that's right. I think that if you add, I've seen data of NLT with a layer of plywood above, which is usually sort of necessary for parge, and then you're in the ballpark of base CLT. But a big another component, not to be the structural flanking guy, is to talk about continuous NLT past the demise wall, because as you said, Felix, now you have actual panels of wood, bars of wood that are going across the wall versus like a thinner wood. And so that is also kind of affected and can be quite tricky to navigate. So I would sort of say in general, no, they're in the same ballpark. Especially if you have like the NLT is covered by something, but they definitely cannot be treated the same.
Yeah, that makes sense. Yeah. All right, Steve.
Okay, and Ben did add a remark to that, said he would love to see comparisons of horizontal flanking through CLT versus DLT and NLT. So maybe that's a good thing to put in your next study there, Simon.
Yeah, we're working on that.
Yep.
Cool.
Let's see. Next question comes from Ashraf Kamal. Do we need any sealant or caulking in joints?
Generally, yes. I guess it depends on the joint and things like that. But I mean, if it's anywhere, I mean, to Simon's analogy, right? Like if you think about water and you have a space where you're trying to contain sound, imagine that you're trying to contain water. And if there's any places where you think water would leak through, then think about it for sounds too, that you need to seal it. I mean, also I think for a lot of architects, I'll often use air barriers as another analogy, right? Because a lot of times architects, especially if you're working in, more sustainable buildings and things like that, which there's probably quite a bit of overlap there with mass timber. Maybe you're used to working with high performance air barriers and those kinds of things. And so there you also need to make sure that you have a continuous air barrier all the way around, and you're very carefully controlling any kind of, penetrations in that primary air barrier. So same sort of thing for this, is like you have some sort of acoustic space, whether it's an apartment or it's a classroom or a C-suite executive office or something like that, where you have, again, this boundary sort of all the way around it, where you're trying to control the sound that's getting in or out of it. And so you need to make sure you have this sort of a continuous area of acoustics, isolation, separation, and air sealing as part of that. So yeah, typically sealant is a thing.
Is it joined for 2 slab of CLT, Mr. Kamal, or otherwhere else?
Yeah, that's a good question too, about where exactly the joint is. So I will say, on that green canopy node data, the one that was the 3-ply plus the 5-ply. So I also in that series have test data on just the bare 5-ply that was used for that assembly. And the first time they went and did it, I wasn't as involved with the tests, and we did the 3-ply 5-ply combination. And then we went back and did another test of that same kind of pedestal assembly, but just on the 5-ply, and they tested the bare 5-ply again. And at that point I had test data for other 5-plys, and this one, the SDC rating was significantly lower. And I was like, hang on a second, this doesn't make sense. Like, what's going on here? Like, these results seem off to me. Well, turns out after some investigation with an acoustic camera and some other things at the lab, that 5-ply CLT was just, the lab opening is 10 foot by 12 foot, and they didn't have one 10 foot by 12 foot panel. They had 2 panels that they had just edge jointed. And oftentimes, I think you mentioned it somewhere, maybe Simon, is that there's a spline that will hold these panels together or something like that. There's different ways that these panels are held together. And in this case, they were just stuck together, and that gap was not sealed. When they noticed this, they went back and they put some just acoustical sealant in that gap, and lo and behold, the SDC rating and the TL values went up significantly. So yes, good point, Felix. When you have these joints between panels, that is something to consider. And what do people typically do on projects? I mean, there's structural joints where you have splines or other things to kind of connect these panels, but in terms of just sealing gaps where they're butted together, what's kind of standard practice?
Well, it depends. Usually there's no, you only got like a screwed connection, and that's pretty much it. But for this specific project, we got discontinuous CLT, and then we placed some viscous material in between both panels, just to see if it would help for the discontinuous panel. So yeah, but I don't have the results yet if it has any improvement.
Okay. Yeah, I usually see, I mean, just from our experience in the field, like I don't think they're really doing much on the underside. They sort of just leave that edge joint, and then like you said, on above it we've got a topping, which is going to be essentially acoustically, that's going to be providing that high frequency addressing the leaks. But usually you've also got either a spline detail or some other structural connection.
Yeah. Okay. All right, Steve, maybe one more, and then we'll call it.
Yeah, we've got only one more in the Q&A here. It comes from Neil Shaw, and his question is, what is the construction of the bulkheads? So he might be looking for a little bit more detail about how those are constructed.
Just a standard bulkhead, one layer of drywall on metal framing with insulation in it.
Yeah, so nothing, just like you build a soffit for your exhaust duct going out or something like that, right? Yeah. Well, Simon, sounds like you need to do another presentation that's just all about bulkheads. And all right, well, thanks everybody for your questions. If you have additional questions, feel free to reach out to us. Felix and Simon, thank you both very much for joining me today. It's great to get to do this with you guys. And thanks everybody for joining us. And yeah, I think there's a link in there. I see Felix just put a link to Woodworks for that. Go check out Acoustic, HGC, and all the data that I showed for the CLT Assemblies is available on PAX Assembly Selector. I think a registration link for that was put in there. I know a lot of folks in here already have access to that, but go check that out. And we're always adding more test data. So thanks everybody, and yeah, hope you have a great day. Mike, and
this recording will be available, correct?
I think so. Yes. Will this be available? Simon, do you have any issues with us? I know some of this is your IP.
No, that's okay.
Stuff like that. Okay, cool. So yeah, so this will be available on the PAC page. There's a webinars page. You can go there and you can see all of our past webinars. And I also will be doing another webinar in about a month. So stay tuned for that. We'll send out more email blasts and check all that out.